Welcome students to the physics class. In the previous class, we have solved some of the numericals based on Gauss's law. And today we will solve some more numericals based on Gauss's law. So the learning objective of the topic are, after the completion of the topic, students will be able to solve the numerical problems based on Gauss's law in given situation. Now, let us discuss some more numerical problems from NCERT book. This is question number 22. The question is, a uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80 microcoulomb per meter square. The first part is, find the charge on the sphere. The second part is, what is the total electric flux leaving the surface of the sphere? Now what we are given over here? We are given a charged conducting sphere whose diameter is 2.4 meter and the radius will be 1.2 meter. And the surface charge density is given, that is sigma is given, that is 80 into 10 to the power minus 6 coulomb per meter square. Now the first part is we have to calculate the charge on the sphere. Now we know the relation between surface charge density and charges. You are aware of the formula, that is sigma is equal to Q upon area. Hence Q will be equal to sigma into A, and since it is a sphere and therefore the area of the sphere will be 4 pi r square, and just simply substitute the values and get the charge. Now the second is we have to calculate the total electric flux leaving the surface, and we know the relation between electric flux and charge, that is phi is equal to Q upon epsilon naught. Substituting the values, we will get the answer, that is 1.6 into 10 to the power 8 Newton meter square per coulomb. Now the next question is 23rd, and the question is, an infinite line charge produces a field of 9 into 10 to the power 4 Newton per coulomb at a distance of 2 centimeter. Calculate the linear charge density. Now what we are given over here? We are given electric field intensity, that is E is equal to 9 into 10 to the power 4 Newton per coulomb, and the observation point is at a distance of 2 into 10 to the power minus 2 meter. And since we are given a charged line and the electric field for a charged line is, that is E is equal to lambda upon 2 pi r epsilon naught, and here we have to calculate lambda, and lambda will be equal to E into 2 pi r epsilon naught, and again simply we have to substitute the values that we are given and we will get the linear charge density, that is the value of lambda will be equal to 10 microcoulomb per meter. Now the next question, 24th question, is again a direct application of Gauss's law. That is, the question is, two large thin metallic plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs and of magnitude 17 into 10 to the power minus 22 coulomb per meter square. Now the question is, what is electric field? A part is in the outer region of the first plate, the second is in the outer region of the second plate, and the third is between the plates. Now beta, you all know that when we are having two parallel plates which are of same charge density but oppositely signed, then the electric field outside the plate is 0 and electric field inside the plate is sigma upon epsilon naught. So here in case of A, the answer will be, it will be simply, that is in the outer region of the first plate E will be equal to 0. In the second case also, in the outer region of the second plate E will be equal to 0, and between the plates E will be equal to, that is in the C case, E will be equal to sigma upon epsilon naught, and simply substitute the values, that is sigma upon epsilon naught, substitute the value for sigma and epsilon naught, we will get the answer, that is E is equal to 1.9 into 10 to the power minus 10 Newton per Coulomb. Now beta, your homework is that you have to complete the question number 15 to 25th of your NCERT books in your physics notebook. Till then, stay healthy and stay blessed.